How's it going?
Oh, it's going. It's going. So I was doing a little bit of research on you, a little bit here and there. I saw a
Okay.
couple of your debates already. It's interesting.
Okay.
So start with me here.
Yeah.
Why do you think the world is flat?
Can I throw it back at you? Why do you think the Earth is a globe?
Well, I mean, based off of your picture you have in the background, everything else is a globe. So why is the Earth
Well,
the only one flat?
Reed, no flat Earth researcher thinks this is true. Okay. We don't believe that we're a disk floating in space with
Okay.
other round planets or other disk planets. We don't believe in space. And we don't believe, that those luminaries that we see in the sky can be reflecting sunlight and be brighter than stars. It doesn't make sense when you scientifically look at it. So let me give you a quick rundown of what flat Earth is and what flat Earth isn't. If that's cool?
Go for it.
All right. So they want us to believe. Where am I? They want us to believe. So this is a balloon shot from 120,000 feet. The Earth should be spinning 1,000 miles an hour below it, but it's not. Somehow the balloon doesn't, um, land out west. It actually land east of where it comes down, which makes no sense because it's outrunning the spin of the Earth.
But
So
is
what
the
is?
balloon tethered?
It's just a no. It's a balloon. It's a weather balloon that we sent up with cameras on it, and
Okay.
the Earth is spinning to the east. It landed east of where it took off from. That makes no sense. On a spinning, rotating Earth. So I'm going to ask you some questions. And by the way, before I became a flat earther, I got them all wrong. So don't feel bad if you get them all wrong. All right.
Okay.
So do you know how fast? Hold on. There we go. Do you know how fast the Earth is spinning at the equator?
Roughly 1,000 miles.
Bingo. And do you know how fast it's orbiting the sun?
I mean, based off of human timelines, it takes us 365 days per
Well,
year.
the speed that it's going around the sun, 66,600 miles an hour, and it's
Okay.
chasing the sun at about a half a million miles an hour. Okay, but
Okay.
somehow, if you go out tonight and look at the stars in the sky at a certain time, make a little chart next year, same night, same time. Even though we're 4.5 billion miles from where we were this year, all the stars are in the exact same position. No parallax, no movement, no nothing. They all are in the exact same position, right? So backing up a little bit, I'm jumping a little forward. What is the flat Earth if we're not a disk floating in space? So they want us to believe that the flat Earth is, I mean, that Antarctica is a continent at the bottom of the ball. You know that they
Okay.
tell us Antarctica is the highest land on Earth? It's the highest plateau on Earth.
But it's not, though.
Well, they tell us it is.
But it's not,
How do you know it's not?
because it's been proven that Mount Everest is the highest
No,
point.
no, 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 no. The plateau, not the heights. And
Oh,
and
the
and I don't
plateau.
know. I don't know if that's true either. There may be mountains taller, but that's not the point. The point I'm trying to make is large bodies of water at rest lay flat, testably, measurably, provably flat, scientifically provably flat. And if the Earth is 24,900 miles around, like they tell us, there's a curvature formula that you can calculate, and there should be things that are hidden over the horizon. A 6 foot tall person standing at the edge of flat water shouldn't be able to see the surface of the water at beyond 3 miles because there's a 6 foot drop, right? But we can see much, much farther than that. So that says one of two things. The Earth is either bigger, much, much bigger, like 1,000 times bigger, or it's flat. So just getting back to my to what goes on with water, the water needs a large body of water at rest lays flat. I said it needs a container. Like if you had a tub and you got rid of the tub, all the water's gone, right? After it rains, water accumulates in a puddle at the low spot in the land, and the container of that puddle is the land all the way around it that's higher. A pond is the bigger puddle. The land is the container. The land that's higher, because if the land was lower on one side of the pond, the water would just flow away, right? This is
Right.
You can agree to all that,
Okay.
right?
Yeah.
So so I'm something moved here. All right. So There it is. Sorry about that. So a pond is a bigger puddle, a lake is a bigger pond, and the world oceans are a giant lake. Well, what's the container, the lateral pressure to hold that water? And that pressure is Antarctica. So instead of Antarctica being a continent on the bottom of the ocean, it's the shoreline of our lake. That's all, right? So we live here. All of the continents, all of the islands are all surrounded by water, but the water is surrounded by the highest land on Earth, which is Antarctica. We live in the Antarctic basin, right? They tell us the world is 70% water. Well, that water is testably, measurably, scientifically, provably flat, right? So where is the curvature? Every experiment we've done over great distances, that things that should be hidden are not hidden. So no curvature, no ball. Now think about this. This scientifically makes sense. Water on the outside of a spinning ball adjacent to with an atmosphere adjacent to a space vacuum, that doesn't make any sense at all. A vacuum should suck all of the air off Earth. But the Globers will go, well, gravity. Well, gravity can't hold the air down, right? I can prove that with a straw. I can put it down and put a little bit of low pressure in my mouth, and water and air will just come right up and away from gravity effortlessly from with a little bit of low pressure. And I wouldn't call that anything to compare to the Tor 17 vacuum of space, right? So space is scientifically impossible. So anything that you hear about space, from space, pictures of Earth, that's coming from a place that's scientifically impossible. So you can't use them as evidence.
So then how do you define gravity?
Good one. Good one. And thanks for asking. And let's just, you're going to have lots of questions come into your head. Write them down if I don't get to them right away. But one thing at a time. So the way gravity works. So when you talk about gravity, did you know that science recently, I forget how long ago, changed it from Newtonian gravity, where the apple falls on your head, to Einsteinian gravity, where the bending of space-time is why planets orbit, the sun, because the sun is bending the fabric of space, and they show us, a big fabric stretched over a drum, and then they drop a bowling ball in the middle, and they throw some balls in, and they go around. That's the bending of space-time. Hypothetical nonsense. Right? Why is space-time bending this way and not that way or that way or that way or up or down? Who determines that? It's all theoretical, complete and total nonsense.
Well, that was based off of Earth's gravity, not the sun's gravity.
Yeah. Well, so what is Earth's gravity? If you watch, if you type in flat Earth gravity, they're going to show you a disc where, as you get closer to the outside of the disc, you have to lean forward because gravity is going to pull you to the center. No flat earther believes that. That's not what we're talking about. So, where is my? Oh, here it is. So the way the world is set up is the sun and the moon are small and they're close. They're the anode and cathode of the Earth battery system. The salt water carries the current. The land is the salt bridge. And if you know how batteries work, this creates a big battery. And the Earth testably has a measurable, what we call a negative charge to it. The air, the sky, has a positive charge. Okay. So anything that lifts up off the ground is now surrounded in that positive charge. The Earth does not move. It doesn't rise up like the Flat Earth Society will tell you. And it says, hey, down is this way, a negative and a positive attract. And then buoyancy and density sort everything else out. If I had a handful of rocks and ping pong balls and a helium balloon, I held them over a pool and I let them go, the rocks and the ping pong balls are going to go down, the rocks will go to the bottom, the ping pong balls will sit on the water, helium balloon will go up. That's buoyancy and density. It just says, hey, down is this way, but you guys sort yourselves out. The balloon goes up because the air is more dense. The rocks go down below the water because they're more dense in the water. The ping pong balls stay on top of the water, fall through the air. Buoyancy and density. So how can we prove this? Well, here is a tinfoil triangle that we put a negative charge into it. Whoop, it goes up. Are we defying gravity? Or are we defying, because it's still connected and we're putting a negative charge into it, it's now, even though it's in this positive field, it's still negatively charged. It's up.
You made a magnet.
No, it's not a magnet.
Yeah, that's exactly what it is. It's negative and positive charges repelling each other.
No, it's two negative. This is a negative charge, right? Well, electricity and magnetism are brother and sister. So here's another one that we did. Okay, this is we had a Van de Graaff generator. We have this balloons, and we tied them to this. There's a metal button on here, and it's connected to the Van de Graaff generator, and it's at equilibrium. It's just a couple inches off the floor. So now we're going to add a positive charge to this. So we're adding a positive charge, and as soon as we add the positive charge, it goes down to the floor.
That's because helium is missing an electrode, and if you add an extra positive
I'm not adding
charge to it,
not
it
to
makes
the
it more
helium.
dense.
I'm not
Yes.
adding it to the helium. I'm adding it to the
What
button.
is attached to the cables there on the ribbons?
Those are ribbons.
Yeah, but the same process goes through. It can carry electrical current.
Okay, so what you're saying is proving our point. The electric charge of everything is what attracts it to the earth. It's not gravity.
No, I'm saying
Gravity-
the helium becomes more dense and more liquefied because that's how you can get liquid helium.
Well, so you're saying the charge of the helium makes it more dense or makes it lighter, whatever charge you have. That's proving my point. It's the charge. It's not gravity. If you ask, the high priest of scientism, Neil deGrasse Tyson, what gravity is, he goes, we don't know what it is. And they have to make up 96% dark matter and dark energy, which is all made up hypothetical nonsense. They admit, Michio Kaku says that the people in the theoretical physics sides never use a scientific method. And, if in science, if you're off by a factor of 1 or 2 or 10, it's horrible. But in theoretical physics, they're off by a factor of 10 to the 120th power.
Well,
Okay?
anybody can have a theoretical degree in theoretical physics.
Right. And they don't use a scientific method. They make up stuff, and never once ever has theoretical physics predicted something correctly.
Right, but I'm talking about the chemistry makeup of helium.
Okay.
Because if you add a positive current to helium, because it has two neutron or electrons to it, adding the positive charge turns it into water, making it more heavier, causing it to come down. That's what I'm talking about.
Well, you're saying that electrical charge is going up through the ribbons. I don't believe that. But even if it did, we're changing the electric potential, which is making things go up and down. It's the same argument. Okay? It's the same argument. So that's what gravity is. Science doesn't know what gravity is, right? But we do know what electricity and magnetism, what electricity and magnetism is. So there you go. There's my answer on that one, and you can look into it. I'm going to show you a place where you can find all this information. You Google anything flat Earth, you get fed nonsense. I'm sure you saw my you probably Googled flat Earth and saw my it was supposed to be an intellectual debate with the guy that calls himself Professor Dave, who's just a shill for YouTube and just pushes, just calls names and stuff and wouldn't address anything real.
Yeah, I saw that debate.
Yeah. But he had nothing other than insults and saying he didn't understand when I tried to explain, why at sunrise in the summer here in Connecticut, I can get a tan, but at noon in the winter, I can't get a tan.
It's actually based off of your skin temperature.
Why in the summer can I feel the heat of the sun on the horizon, and in the winter I can't feel the heat of the sun when it's at its highest point for the day?
So working outside personally, if you're outside in the winter and everything is more colder, your skin has to compensate for having an evenly heat discharge. Adding more sun without having that cold element causes your skin to tan and feel more warm. Like I'm quarter Latino right now because this arm is completely tan and the other one is white. Like, I don't know if the camera's picking it up too well.
I see it. So why is it in the winter, in December, when I look at the sun, I can't feel the heat on my face when it's at its highest point for the day? It's 3.5 million miles closer to me in my winter than it is in my summer. And then at the most severe tilt, going through the thickest part of the atmosphere in the summer, as soon as it shows up on the horizon, I can feel the heat and get a tan. So and it's 3.5 million miles farther away.
Hold on. You're saying the sun is closer during the winter?
Yep. In the heliocentric model, it is. That's what the heliocentric model says. In our northern.
It doesn't.
Okay, write that down because we're not going to look it up right now, but go look it up. You're wrong. It's closer. We're 3.5 million miles closer. Because if that wasn't true, then it would be true in the south, right?
But
it has to be true for one of them.
During our northern hemisphere summer, the southern hemisphere has their winter, and
Correct.
vice versa.
Right. So one of us has to be closer during our winter, and one of us has to be farther during our winter.
But the change is only about 30 miles, give or take.
3.5 million miles.
Okay, you're gonna have to send me the sources on that one.
You can just look it up. How far is the sun from the Earth?
I want to compare notes with your sources on that one.
I've looked it up a million times, right?
Okay, so then you should have the sources for it, but continue.
Yeah. So what can you give me a so let's we look at let's look at the curvature, if you will. Okay. So here's a viewing spot in Illusia, France. We're looking out over the ocean, and Mount Canigou is out here 175 miles away. Using the globe Earth calculator, the top of Mount Canigou should be over a half a mile below the surface of the Earth from this height, using the Earth curve calculator. Not our Earth curve calculator, theirs. And we can't see it. We see a horizon, can't see it. Now, the sunlight that's bouncing off of Mount Canigou, that sunlight can't push through the thickness of the atmosphere and go 175 miles. We just don't see it. We don't see that reflected light, which is the mountain. You don't see me. You see the reflected light off of me. If I turned off all the lights in the air, you wouldn't see me. Right. But twice a year, when the sun's migrating in between the tropics, at one point, it lines right up with Mount Canigou. And as it goes beyond it, it backlights it. And then all of a sudden, you can see it right here. And the very top over here should be a half a mile or more below, and I'm rounding down, below the curve. But the entire mountain is right here. The entire mountain is right here. So this would mean that the Earth would have to be dozens of times bigger than they're telling us. And we use infrared. Now, one of our guys that is good with all of that equipment, he's seeing stuff over 1,000 miles away, which means the Earth would have to be 1,000 times bigger than it is, and you would still measure curvature. But this is Mount Canigou. It's not a mirage. It's right there. It should be below the curve. It's not. We can see too far. So people say, well, maybe you're going to come up with it is, what about boats over the horizon? Well, here we are. We're zooming in. There's nothing here on the horizon. But as you zoom in, what you do is you increasing the angular size of things. And as you increase it, you can see that there's a boat there, okay? Because I'm just increasing the angular size. Your eye can't see it when it gets too small. So watch, I zoom out now, and it's going to disappear from the bottom up because these little waves in the foreground are closer, and they're going to hide the boat. It gets so small, you can't see it. Now, a glober would say, oh, it's over the curve, but it's not over the curve. It's right there, and just zooming in with today's consumer optics have outrun their lies. Here's a shot of a known distance, not a boat. We know that this is 9.4 miles away. The camera is a foot above the water. So that means that the horizon should be 1.2 miles away, right? So there should be 59 feet of curvature at this second rig. But not only is there not 59 feet of curvature, we can see the water way, way beyond it. There's a whole bunch of videos that zoom in, and you can see the water, the surface of the water. The surface of the water. That means there's no curvature. Okay, curvature is an optical thing, okay? It's an optical thing. And when we look into the distance, so look at this boat here. The entire back deck, I can't speak. The entire back deck of the boat is hidden behind this wave right here. So as you zoom out, the boat looks like it's hiding behind the horizon because all of this just merges into the horizon, and all you see is stuff that you have a larger view of. It's optical. It's optical. So here is something that's even taller, Space Needle. Watch when we zoom out. When we zoom out from this location, not only do these buildings disappear, the entire city disappears. It's there. It's not a mirage. It's just you can't see it. Our eyes don't work that way. The horizon looks empty. Okay? And these are things that you can go do yourself. Like when I first started seeing this, I was trying to disprove flat Earth and prove the globe. And I started seeing this, and I went out and I bought a Nikon P900 super zoom camera, went to the beach, started zooming in on things. I'm like, I should not be able to see that. And I can. Interesting, right? Can you get it interesting?
So pretty much what it comes down to is the speculation of how big the Earth size is. Because if the case is that it's actually flat, then you should be able to see everything across the Atlantic. Then
Didn't
you
I just
should.
show you that we couldn't see Mount Canigou at 175 miles away because of the atmospheric density? And what could we possibly see that's big enough that wouldn't merge into the horizon at that distance? You can't zoom past opacity, right? You can only zoom as far as the atmosphere will let you see. You look through a pane glass of a window, it's perfectly clear. Stack 10 glasses together, it's a little fuzzy. Stack 100, you can't even see light on the other side, right? Because the medium will block your view. A medium will block your view. Let me show you an example of that. So this is a video that I actually filmed, and where is it? Here we go. So I have this can only be filmed when there's no humidity. It has to be below freezing, usually, because that helps with the no humidity. I have my drone up, and the sun. Well, where am I? Here I am. Here I am. So let me just back this up a little bit. So I have my drone up, and in 5 minutes time, the sun went like this. It went down, 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 down. And then if the earth was spinning, it should just keep going, but it didn't. It went down, 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 and then it stopped. And it sat here for 10 minutes. Now watch what happens. This is sitting here for 10 minutes. If the earth was spinning, it would keep on going down, but it didn't. It sat here, and as it's getting farther away, what happens? It just fades into the opacity. There is where the atmosphere becomes opaque at that distance, and it's gone. It's still there. You just can't see its light. And that's brighter than the light reflecting off of any land feature, right? The sun is the lightest, the brightest light in the sky, right? So,
Yeah.
so that's just showing you how light doesn't travel forever. They want you to believe, that light travels for billions and trillions of miles, right? Here we have a sunset in Bulgaria. Now, is the sun just going away, or are you falling over backwards faster than the speed of sound? It's just going away, and as it goes away, it gets into more and more dense air, and it takes its light with it. Its light just goes away. Now, if I was underneath that sun, it would be high in the sky and it'd be bright as day. But it's nighttime over here because the sun has gone away. It's going away, and it just takes its light with it. Now, it's not going behind a curve there, and I'll show you that. So here's another one. This is done in Afghanistan. One of our volunteers to be a soldier did it. And the sun is just going away, sped up, of course. And it's dry, it's clear, and it's not going down. It's going away and getting smaller and smaller and smaller. So I'm going to show you a quick experiment I did, and this will help you understand how perspective works like that. All right, so here we go. So here, this line is level. Here's my counter. It's level with this line, and I'm moving the sun across it. Now, this can be a cloud deck. It could be mountains. It could be atmosphere. It could be a city skyline. It's just we didn't go below it, and the line is level. Now, I have a camera on the other end where I started on the table down below this, looking this way, right? And when we look at it from that perspective, look at this line. If I said, is this line level? You'd say, no, it's sloping down. And I'd say, is the sun going below this obstruction? And you'd be like, oh, yes, it is, because it's going down this sloped line. But this is a level line, okay? And this horizon looks like it's at eye level, but it's really way above me, okay? If I had a longer kitchen, it'd be even better, right? So this is the sun setting beyond it, even though it didn't go below it. Now, here's a real sunset, okay? Here's a real sunset over here. Look, what's this horizon? What is it going behind? This is the atmospheric deck of opacity where the atmosphere just becomes too dense. Here it is one more time. It looks exactly like what I'm doing here. The sun looks like it's going down and it's going behind there. It's taking its light with it. And that's that. Can I get an interesting?
I mean, it's unique for sure.
Oh, I'll take a unique. Well, it's not really unique.
Well,
but
I've
it's
never
a-
seen this kind of experiment and side by side before.
Thank you. That's all I'm saying. Because here, I was you 7 years ago. I was you. And I actually wasn't as open-minded as you. I wouldn't have talked to me. I would be like, get out of here, you're retarded. I actually banned people from our podcast social media for even suggesting that I go look at a stupid flat earth video, right?
Did
But
you
then
even read the byline from a podcast then? Because I'm open to anything.
I saw that, and that's awesome. I'm pointing out that I was not. You're more open than me. And then I was like, I never thought about that. I never looked at it that way. I never realized that. I was told boats go over the horizon. If the earth was a ball, check this out. If the earth was a ball, my fingernail is a boat, it disappears behind the horizon, a physical horizon. This is a physical horizon. Here, and now if I zoom in, you still can't see the boat because the horizon is physical. But when we zoom in, like I showed you, we're bringing things back into view. We're bringing things back into view. So, interesting. So here, this is my app, the Flat Earth, Sun, Moon, and Zodiac Clock app. If I go to the frequently asked questions page, and right here it says ships over the horizon. If I click that, up comes a bunch of videos that YouTube doesn't want you to see. These are amazing videos that really document what you're seeing, how it works, and you can watch these videos. You don't need to because they're real well documented, or you can go out and get your own camera and do it yourself, and that's what I did. And that's how you can know that boats are not going over a physical horizon. Circumnavigation? Questions? Anything?
My one question was, you said the stars are in the same spot all the time, right?
No, they repeat. They move through the sky at night, right? The North Star always stays right where it is, right? We're corkscrewing through space, right? We're going through space, going all these crazy directions at once, but somehow all of the stars repeat their positions exactly every year, except of course the wandering stars, which now are called planets. They never change, right? The stars change hourly. We're moving, when you're going down the road, the trees right next to the car are whizzing by fast, the signs and everything, but the trees on the top of the mountain are moving really slow because the mountain's in the distance. It's called parallax. When you're moving, things change their orientation, right? But the stars never parallax, ever. Absolutely not, right? Do you know about the Georgia Guidestones?
I believe it's written in 15 different languages in case of an apocalypse.
Yeah. So, well, in case of the planned apocalypse, but that's a whole nother rabbit hole. But in the center stone, there's this little hole, right? You got to remember, we're corkscrewing, going through all these different directions. You look through that little hole, and what do you see? You see Polaris. You do a time lapse, and all of the stars are spinning around here. Now, how the heck is that possible when every 6 months we're 186 million miles on the other side of the sun, ignoring the 500,000 miles an hour that the sun is moving through space, never to return to where it was before? How the hell does this hole still point to Polaris? Here's the global explanation. Polaris is so far away that movement of 4.5 billion miles a year is insignificant and it doesn't move. That's absolutely ridiculous. All right. But they also say that our North Star wasn't always there. 4,000 years ago, it was Thuban, and in 4,000 years, it's going to be another star. We just happen to live in the time where there is a star at the north. Okay. Well, if that was true, then over the last 70 years or last 40 years, we should have moved almost a degree or over a half a degree, and a half a degree would knock it right out of there. A half a degree is the width of the moon, right? Well, this hole is very tiny, and it hasn't moved. It's still there. It's been up for over 40 years. And then there's pyramids. The Egyptian pyramids have been up longer than 40 years. They still line up with the same stars that they were lined up with. This proves that the stars that we see are all the same distance. They're fixed within the firmament and they're spinning above us. But here's the thing. The optics of the sky are no way to prove the shape of the earth. The optics of the sky are no way to prove the shape of the earth because we don't know what that is. We've sent balloons up and all the stars disappear. I flew from California to Australia at the middle of the night. I was so excited. This is long before I was a flat earther. I wanted to see the stars. I'm like, oh my God, the Milky Way is going to be amazing. No stars. There was like 5 stars. Less than 5. There was like just a couple. And like the whole time I kept looking out. The lights were off in the cabin. I'm like looking out. The window was clean. No stars. What's up with that? Makes no sense in a heliocentric world. We are programmed to believe that we're spinning out of control, lost in space, that we're insignificant. The elite, I think we might be on the same page in some of this, don't want us to know who we truly are, the true power that we have. They don't want us to know that we're at the center of creation, that this place was created for us. They don't want us to know that we don't use just 10% of our brains. We use 100%. But the indoctrination system run by the Rockefellers wants us only to use the 10% to make us good slaves, teaches us algebra, calculus, accounting. They want us to be good little worker slaves. They don't teach us sacred geometry. They don't teach us vortex mathematics. They don't teach us how to connect with nature, how to connect with spirit. They don't teach us how to use our imagination and create the world that we were born into, which was our birthright. They don't teach us that nobody has authority over us other than in our imagination. And that's what this does. The heliocentric system is the matrix. It's a prison for your mind. And once you unplug from it, you can't unsee it. Once you see it, you can't unsee it. Hey, what state are you in?
Indiana.
Indiana.
Yeah.
Okay. I was going to say, if you're south, we have a conference in October called Flattoberfest. Amazing people, amazing place. If you're close by, just say, come on by, check it out.
Oh, I was the background. You see my wife walk by. I joked to her not too long ago. I said, we should go to Texas and go for the hog hunting. They're paying $50 a tusk.
What are they trying to wipe out hogs?
So the completely irrelevant. The hogs are overpopulating Texas right now, and they're causing issues with their wildlife and the cattle. They'll break in and actually fight cattle for the food that they're laid out. They're considered a nuisance, and the DNR opened up and said unrestricted shooting. And for $3,000, you can get a helicopter ride and shoot as many as you want.
Well,
everything you kill is donated to a homeless shelter.
Interesting.
So it's a vacation idea.
Interesting. Here's another monument. Every year on 11/11 at 11:11 a.m., the sun lines up with all of these holes and lights up this memorial, this war memorial. All right, cool. But how the hell does that happen in a spiraling, corkscrewing, heliocentric insanity beehive solar system? Okay, how come the sun can hold on to the Venus and Mercury and the Earth and Saturn and Jupiter and Pluto and Neptune, right? But it can't affect any of their moons. How come when our moon comes around our Earth towards the sun, it doesn't speed up, and when it goes away, it doesn't slow down, right? People go, well, the Earth's gravity overpowers the sun. That's ridiculous, okay? If gravity is what they tell us, gravity affects everything. There can be more than one gravity. The gravity of the sun doesn't affect the moon, but we can put satellites into a what's it called, where they put it halfway between the sun and the moon. It's called Lagrange point, where the gravity equals it out. Well, why can the gravity equal a satellite and hold it in place, but it can't affect a moon? How come it can't, pull on a moon? All of this is absolute insanity. And once you look at it, the lie is so big, people can't see it. Right?
So I'm going to try and test this one.
Go.
So based off your argument of what gravity was with the positive negative cycle and the Earth being a positive negative charge grounding almost, the moon could be essentially the same thing. So if anything, the magnetic charges between the two, or electrical charges, however you want to put it, between the two can actually hold it in place. Using your logic, that is possible.
So, they tell us that the moon, sure, that you could say that's possible. The moon is that's not the Earth. So the moon, and don't give me crap about the size. The moon is tidally locked, so we only see one side. It always faces the Earth, right?
Right.
What's up with Jupiter? Every photo of Jupiter shows the same size of Jupiter, no matter what time of year or where on Earth it's taken. It's always the same size with the red dot. Is Jupiter gravitationally locked to the Earth?
To my knowledge, is supposed to be gravity locked to based off of the other planets and the sun as a major contributor. But then again, Jupiter is also, I think they said 70% gas. It's actually the size of Mars. As a whole, the solid part of it's the size of Mars. The rest of it is just gas.
Yeah. So this is a photo in 2014, famous photo, quotation marks. And then in 2016, they go, oh, we found out that Jupiter has a multimagnetic core like Earth because we got a picture of the northern lights. This is an actual photo from NASA. And then when we pointed out, well, these are 2.5 years apart. Why is every cloud the same? And NASA's answer was, oh, well, we took a picture of Jupiter and then we took off the northern lights and we stuck them on the old photo just for better clarity. That's what they said.
Okay.
That's ridiculous. Why would they not show us the photo that they took that showed the northern lights? They took it off and photoshopped it on an old picture to show us. That's what they tell us.
Right.
If you don't have a problem with that, I don't know. I mean,
NASA's a slush fund for whatever Blackwater project they want to do anyways.
I like that. I'll take that. This is what they showed us years ago.
The Hubble telescope. Yeah, that one.
No, this was an actual probe that was going towards Jupiter. And so we're seeing the clouds move and everything, but those two pictures, the Jupiter hasn't changed. It hasn't changed.
Okay.
So, and then we can look at
see, I know the Hubble telescope took 60 shots of the Jupiter in about the same 30-second span. And so that looks very familiar to the one that the Hubble did.
Yeah. So they're talking about the Hubble again in fake impossible space. Therefore, the Hubble isn't real. We had a conversation with the guy that runs Hubble. One of our guys talked to him for quite some time. And the guy admitted that he's never seen an image from Hubble. It all comes through NASA, and it's like he's never seen not a live picture, a direct image from Hubble. And we showed him that Sophia is a telescope mounted in the side of a 747, is where these images are coming from. Hubble doesn't exist, right? Hubble in space is just theoretically impossible. One, they tell us that it's 2,000 or 3,000 degrees where it is. There's no metal that could stand that, right?
Well, not during that time, no.
Well, look at this. This is a picture of Hubble, right? Is this a picture of Hubble, or is it made a can of Del Monte green beans, a soda can wrapped in tinfoil with some little airplane wheels on it, from your Balsa Wood airplane, right? This is what they show us, right? It's literally a freaking garbage can. And then recently, just this year, they did a service mission on Hubble, and they show this picture. It's the same friggin' picture. They couldn't get a new picture of Hubble, right?
Okay.
Think about this. Hubble takes these deep space pictures to show us these, deep things far, far in space. Here on Earth, they have these telescopes that are taking the deep field picture, and it's a
Yes.
long exposure. And so it's calculating the spin of the Earth. Okay. And the technician has to not wear shoes, wear socks and tiptoe around because the vibration in the floor could ruin the whole photo. Right. This is what they tell us. Right. And the pad that it's on is like 10-foot thick cement. So it's totally solid. Right. So it won't vibrate at all. Are they forgetting that the Earth is spinning at 1,000 miles an hour, orbiting at 66,000 miles an hour, and chasing the sun at 500,000 miles per hour? What about those motions? And to make it worse, Hubble is doing all of those things, and it's falling at 17,500 miles an hour just to keep up with the Earth.
Okay.
It's moving in 4 different directions, and it's able to take a long exposure photograph. This makes zero sense. This is scientifically impossible nonsense. Right? And show me a picture from Hubble that's not a cartoon. They're all cartoons. Show me a picture of a satellite in space. Google satellites in space, and you'll see that you get nothing but cartoons. Supposedly these are all satellites, right? But satellites in space, they're all absolute cartoons. Here's one. People say, what about the Himawari 8? The Japanese satellite takes a picture of Earth every 10 minutes, right? We found somebody tipped us off to a NASA server that had all of the images that they use for this. And basically they had the blue marble, which was just the Earth set, and then they had all the weather data from all of the weather stations, and they wrap it around Photoshop. And we found a folder. There's tens of thousands of folders, and we found all of the stuff how they make this. Let me just jump forward here. So here's the weather stuff, and they wrap it all around. Hold on, let me go a little farther. And here's what it looks like raw. Then they have to put in a Terminator line, right? So it's better to watch this video. So they put in the shadow, but we have the image where we can see all the clouds over here. How did that happen if this is real, right? We've absolutely proven that the Himawari 8 is not real because it's in fake space, so nothing could be real. And we've proven it. And again, all of these videos, you can't find these on YouTube, right? Here's the shadows. How do we see these if this was black like this, right? Where did this come from? And this is absolute 100% proof that the space shuttle is nonsense. But if you go into the Platter, Sun, Moon, and Zodiac Clock app, and you hit what about satellites? Where are the satellites?
Looks like it's the top right.
Oh, top right. Thank you. What about satellites? Up comes all of these videos, right? About how satellites are balloons. Okay. But all of these videos will show you, and that Himawari 8 one is in there also. And it'll basically, if you watch those videos, then you'll know that it's absolute and total nonsense. They used to admit satellites were hanging on balloons, then all of a sudden they're falling around the Earth, and now they're switching back to balloons. NASA soon to put more efficient satellites hanging from balloons. They've been doing that the whole time. NASA admits they have tens of thousands of balloons up all the time. So again, you can't find this information online. It's all here. I have, for those of you listening or for yourself, the Flat Earth App Challenge. Every day there's a new video right here. Watch the video every day for 2 weeks. Watch it while you're having breakfast. Short ones during the week, longer ones on the weekend. Just tap that, and up comes the video. And after 2 weeks, I guarantee you won't believe you live on a globe anymore. Okay? If you do, you think you have a proof, send it to me. And if it's a proof of the globe, I'll give you 3 Bitcoins. But before you do, you have to hit the frequently asked questions. Make sure it's not there. It is. And then you can start over again. If you don't want to wait the 2 weeks, you can hit this button right here, and up comes the entire month and the previous months and the previous years. Indulge. Just watch 14 videos, and there's no unseeing what you can now see. So,
okay.
So let me just hit circumnavigation real quick for you, because people say, what about circumnavigation? I could leave New York. I could head east. I can follow a heading of east and end up right back to where I want. Billions of people have circumnavigated in airplanes east to west. 0 have done it south. Nobody has gone south and come up the other side. Why is that?
Because the magnetic field interrupts with altitude pressure gauges.
They go pretty close to the North Pole, they go over, but no one goes over the South Pole or even cuts across the bottom of the globe. And here's why. Here's our magnetic north, and the compass is pointing north, and I'm trying to push this west. I have to keep turning. To head 270 west, I have to keep turning. West is a circle. This doesn't prove the Earth is a globe because it's the same. It doesn't prove it's flat because it's the same on both. If I want to go east, 90 degrees east, I have to keep turning because that needle has to stay pointing towards the center. And I have to keep turning. Now, if I want to dead reckon west, so west is that way right there, and I'm not going to correct to the north. I'm just going to dead reckon west. I'm heading south. Unless I turn to the right, I'm heading south. South is every direction.
Why is that map distorted so badly, though?
Why is the globe distorted, you mean? Because this is the best map that we have, and it actually has been used for navigation for many years. The globe is made up. This is the map that was in all schools, all libraries for the longest period of time. It's the Gleason's map, right? Antarctica is here. This is Antarctica all around us. Matches the UN map. It matches all of the, the big organizations that run the world. They all use this map as their logo. Wonder why? Okay, but when you wrap this around a globe, huge sections of the ocean disappear because you have to cut them out, and there's huge sections of uncharted oceans. So when you say, why is this map distorted? It's because you're used to looking at a stupid globe, which is fake, right? You're used to looking at this, which isn't real. Okay. Antarctica, no, go look at pictures of Antarctica from space. There are none. They're all cartoons.
Yeah, okay, but based on your same logic, though, you said that anything in space is pretty much fake. So anything that could be done from a satellite, supposed satellite, will use your terms, is going to be fake and cartoonish anyways.
100%. I'm with you.
So then at that point, what stops Jupiter and any other of the planets or the stars from being just fake anyways? Using your logic.
I'm with you. So so when we see Jupiter or when we see a planet, Jupiter, Mars, Venus, what are we seeing? What is that light that we're seeing? Is it the light? Is it? Are they burning themselves? Are they their own lights, or are we seeing the sun that's reflecting off of them?
I don't know. I'm asking you. I don't know.
Well, in the heliocentric model, it's the sun that's reflecting off the planet that we're seeing. Okay. So here on Earth, if the sun was a mile over your head, it would look like that when you look up. It would just fill the whole sky. Then we move it 93 miles away. It gets so small, it's the size of a coin held at arm's length. And it got smaller due to perspective. So 93 million miles away makes it go from filling the entire sky, if it was a mile over your head, and bring it away. It's now the size of a coin held at arm's length. How much smaller would it get if I doubled that distance?
Probably the size of a dime.
Okay. How much smaller would it get if I made it 24 times that distance?
You mean I don't have a sewing button or needle next to me.
I'm with you. So remember, it went from the entire sky horizon to the size of a coin. Now people say, well, if you double the distance, it's only half the size. That's not true. It gets much smaller, much faster. But let's pretend that's true. So double, get it to 24 times. Its angular size is scientifically too small, scientifically provably too small to see. Okay. Are you with me?
Well, I mean, also with the thing of saying, like, with the perspective of the atmosphere density that you were talking about earlier.
Well, we're looking up, and the atmosphere gets pretty thin pretty quick. It's only when you look across do you get that density. When you look up, we can see the stars, right? But think about this. If the sun is 24 times as far, that's 3 light hours. It's scientifically provably too small to see, and the brightness is a whole nother issue if you invoke the inverse square law of light. But we'll leave that out. So 24 times the distance is 3 light hours. You can't see it. Well, Polaris is 48 times bigger than the sun. So 48 times 3 hours is 6 light days. Polaris at 6 light days would be the same size as the sun, too small for your eye to see. At 6 light days away, you could not see Polaris, scientifically provable with your naked eye. However, we can see Polaris and it's 433 light years away, right? I'm going to give you one more thing and then maybe we'll wrap it up. Is the sun, they tell us these stars are trillions and trillions and trillions of miles away, right? The closest star is Alpha Centauri, they tell us, 25 trillion miles away, 4.5 light years. 25 trillion friggin' miles away. How long is 1 trillion seconds? You know?
Roughly 36 years.
Close. 31,000 years. Okay. 1 trillion seconds is
1 trillion. 1 trillion. Okay.
Yeah. No problem. No. 31,000 years. So if you're traveling faster than any human has ever traveled at a mile per second, and you went for 1 trillion seconds, you're traveling for 31,000 years, and you are now 1/25th of the way to the closest star. You got to do that 24 more times, and all of the other stars are magnitudes farther. Okay. And you think you can see that star with your naked eye? Okay. You think you can see Jupiter at the distance it is, reflecting it from a distant sun. The sun from Jupiter, if you were on Jupiter or Mars, the sun is smaller than we see it on Earth because it's farther. That smaller sun is lighting up Jupiter and Mars, and that light is reflecting back to Earth, to your eye, and it looks brighter than a star. All of this is absolute garbage that you just have to believe and not think about it, because if you think about it, you won't believe it. You'll know it's not true. All of this is scientifically provably impossible. And the other problem is, as those stars get farther and farther away, you have to increase the brightness magnitudes. When we see the moon, the full moon, that's like about 1 lumen, right? But you can read by it. It casts a shadow on the ground. But you get halfway to the moon, the inverse square law of light says it'll be 4 lumens. Cut that in half, it's 16 lumens. Cut that in half, 64 lumens. When you get to 100 miles from the moon would have to be 64 times brighter than we see the sun for us to be able to see the moon the way we see it here on Earth, right? So that proves that we never went to the moon, right? Because it would be brighter. It would be 64 times brighter than the sun just so we can see it here on Earth. The inverse square law is like a balloon. If I had a balloon with just a tiny bit of air in it, that rubber is the light. If the balloon was a light, and I blow it up to a foot wide, now that rubber is thinner because that light has to spread out and fill all of that area. I blow it up to 5 feet wide. That rubber is getting pretty thin. I blow it up to 1,000 miles wide. Is there any plastic left? Is there any light left? That light is inversely getting dimmer and dimmer and dimmer, just like I showed you where the sun went away. It's light, that's through the atmosphere, but just even in space, light is spreading. It's spreading. It has to fill all of that area. It's not making new light. It's taking that light and spreading it thinner and thinner and thinner and thinner. These are scientifically provable impossibilities for what we experience here on Earth. Your common sense, everything you feel and know deep in your soul, that your common sense tells you that we're flat and stationary, we're not moving. And every experiment ever done to prove axial rotation or curvature has failed and proven the opposite. But they don't teach you about Airy's failure or about Michelson and Morley or about any of these experiments by renowned scientists that went to prove the globe and failed and proved the opposite. They don't tell you about any of this because once you unplug from the heliocentric matrix, you no longer feed the system. You no longer allow people to control your mind with the news, right? They no longer you're no longer afraid of their nonsense. And that's it. The only power people have over you is in your imagination.
So I'm gonna ask you something, and it's okay to be wrong.
Okay.
So based on everything I've heard, it sounds to me like you think that we live on the Garden of Eden then.
I don't say that.
Because you said it was created for mankind.
Well, we live in the center of creation. Okay. So,
Right.
so here's one way that again, anything beyond the shoreline of Antarctica is anything beyond the shoreline is questionable. Like we don't know what's beyond this shoreline because we're not allowed to go there, right? You could spend 10, 20, $30,000, $40,000, and they'll take you right here to this little island. They'll show you some penguin and some ice, but they don't allow you to explore these outer lands, right? What could be out there? Well, let's say we look at it this way and say, maybe we live here in this inner space. This is Antarctica. And out here is extra land, extra terra, extra territory, extra land. So if someone lived out here and they came in here to visit, they would be considered an extraterrestrial from outer space. Okay. Here on the Earth plane. Then what's out here? Are there more? Are there more rings? Are there more puddles? Right? Is it set up like this? Right? Or are there other puddles with other suns? Right? There's so much. And here's the thing. We don't know. We're not allowed to go there, but we want the right. We have the right. We want the ability to go explore these places. They won't let anyone go to the North Pole or the South. There is no South Pole, but they won't allow us to go there. They've demonized airships. They demonized hydrogen with the Hindenburg, which was a false flag. And they've monopolized all of the helium on Earth, so nobody can start a company because you can't get enough helium.
I mean, you can make your own helium. That's not an issue.
Well, you can, but you're not going to get licenses. They're not going to let you start an airship company. Yeah, you can make a small blimp and go film some football games, but that's highly regulated also.
I mean, go to Chile. They have no restrictions when it comes to helium creation because that's where our country gets 80% of our helium intake from is Chile.
There's a helium shortage. NASA owns all of the helium companies in the world.
Right. They get it from Chile because they make it there.
Yeah, well, you can't just go and buy huge amounts of helium.
No, but you can buy hydrogen and boil it and then collect it in and charge it to make helium.
There you go.
Like it's not against the law by any means.
Yeah.
It's considered an explosive only if you don't have it in the regulated tanks, but that's where it comes down to. But yeah, you're able to make your own helium. That's not an issue.
I get it.
Just like how you can make your own gunpowder.
So here's the thing. Anybody wants to collect the Bitcoins, take the Flat Earth app challenge. It's called the Flat Earth Sun, Moon, and Zodiac Clock app. Watch the videos, make up your own mind. Don't believe crazy Flat Earth Dave. Just watch the videos, do your own experiments. All the stuff is documented right here in the app. If you go into the more resources page, we have laser tests. We have all sorts of long distance stuff, all documented, laid out for you. So you don't have to do it yourself. We'll show you that there is no curvature. There is no rotation. And the Earth isn't what they're telling us. So as far as the Garden of Eden thing, we're here at the center of creation, right? Who the creator is, that's your own journey. I don't know. I don't know who it is. Everyone has their own journey on what that is. And there's so many different ways to look at it. I'm not saying that any of them are wrong or any of them, I don't know. I don't know, but that's your personal journey. Everything can be found. All my short videos, if you don't want to get the app, that's fine. Go to flatearthdave.com and take the crash course. It's just a series of videos. If you watch the first 3, you too can lose the respect of your family and friends because you'll be a flat earther.
I watched the first 3 videos of that. I did.
You watch level? The next level?
The first 3 in the crash course.
Oh, nice.
I watched
There
those.
you go.
I got a driving job, so I can throw my phone up and just listen to it. So it's pretty good.
That's good. And guess what? You'll never be bored with driving again. There's so much content to listen to. There's so much stuff. Go hit the homeschooling button on the app. There's podcasts on there that will blow your mind, make you smarter than any college kid ever.
I mean, I'm smarter than a lot of college kids now. But
of course.
Besides the point.
There you go. Well, there you go.
All right, Dave. If anybody wants to reach out to you, how can they do it?
flatearthdave.com. The links are there. Info at the flatearthpodcast.com. But I get tons of emails, so keep it brief, keep it to the point. Don't just send me a link because I won't click it. If you want to book me for a show, flatearthdave.com, book Dave. If you have an issue with the app, support on the app. Download the app. Check out my DITRH channel, which is this logo, all short videos, most of them under 5 minutes, right? Yeah. Cool short videos. I got about, I don't know, 85,000 subs right now. And then my interviews, I have this interview and other interviews are all on the app. They're all linked on the website, flatearthdave.com.
Okay.
All right. Send me a link when this is up. I'll put you on the top of the list and we'll go from there.
It'll be about 3 hours because of small edits. I'm going to add some small edits to it. I'm not cutting any of the conversation.
No worries.
Don't worry about that. But also the upload time.
All right. Are you gonna make a nice thumbnail?
I'm not sure what to do with the thumbnail yet. I've been experimenting with Photoshop lately, so I've been doing weird things.
Don't put a friggin' disc floating in space. I'll send you this image if you want to use it.
Oh, I had a few ideas of what to do.
So. All right, but if you put a disc floating in space, that's called a straw man. And you can do whatever you want. It's your video. It's okay. But that's not fair because we're not a disc floating in space.
Okay.
All right. Peace.
Well, thank you so much.
All right, man. Thanks. See ya.
Yep. We'll see ya.
Bye-bye.
Well, that was interesting. I can't say that my mind was changed, but I can say he brings a lot of interesting points that I think a smarter man than me needs to come forward and actually try. Until then, everyone have a great night.